Okay, the next step in the lab says to modify the allowed VLANs on the trunk interfaces to prevent VLAN 4 from crossing the trunks. So there may be some scenario where you have a switch over here that's doing some special stuff with VLAN like 99 on it, for example, and you don't want that VLAN 99 traffic to make it back over to these other switches. So you can do that by disallowing that traffic to cross the trunk. So the command to do that is you go into the interface you're worried about setting. In this case, I'll go into gig 1/1, which I think I'm already on. 1/1. And then I'll do the command switch port, trunk, allowed, VLAN, except 4. So what that's going to do is that's going to allow all VLANs except 4. And this will, if we do show int trunk, we now see that for our gig 1/1 port, VLANs allowed and active in the management domain says 1, 2, and 3. So if I decided I wanted to add VLAN 3, I couldn't do the same command because that's going to change the command to add everything except for 3, I think. Let's verify that. Yeah, so it put 4 back and took 3 out. So if I want to do 3 and 4, I can do, I think it was, what did the command say? Remove. And now if I look at the settings, that didn't work. Removed. I want to remove 4. Yeah, so now I've taken 3 and 4 back off. So if I want to put them back on, I can do all. So there we go. So anyway, to exercise this, we want to remove 4. Right? We want to do that on both interfaces. Now we see 4 is not allowed across the trunk. So if I ping from a VLAN 4 PC and try to ping another VLAN 4 PC, it's not going to work because we removed that information from the allowed VLANs list. So that's that. I'm going to go ahead and put those back on so that everything will work as it's supposed to later on. I'm going to go into 1/1 and do the same thing. And now I verify that actually worked. So now they're all back on. My ping should work now. Check that out. So that's that. The next step says to copy your entire network and paste it. So we'll select everything. So we'll select everything. And we'll copy. And we'll paste. Right? We'll move it over. Make this smaller so we don't have it in our way. Alright, then it says do not connect the networks together at this point. Later on we're going to connect the networks together. But right now it says do not connect the networks together at this point. Change the PC IP addresses. So remember, since we copied them, we need to change the IPs so they don't conflict. Although it already removed IPs for us. It's such a great, helpful tool. Alright, so VLAN, I've got .1, I mean .2, .3, and .4, so I'll go 2.5. 2.5, 3.5, 4.5, and then we'll do 2.6, 3.6, and 4.6. 3.6, 4.6, And we'll do 4.7, 2.7, 3.7, 4.7. 2.7, 3.7, and 4.7. What am I doing? Alright, so now our PCs are set. We should be able to ping among VLANs over here, not among, in the same VLAN. 2.56. Alright, I can't ping 2.2, right? Because 2.2 is not connected at this point. So even though I have VLAN 2, 3, and 4 over here, and VLAN 2, 3, and 4 over here, there's nothing but air between them. So we won't be able to ping across until we connect it. So now we're going to talk about VTP. VTP is a VLAN trunking protocol. It's a way that we can add information to one switch and have it be populated over to a different switch. So step says modify the Vtp configuration. Set one of your switches in client mode, one in transparent mode, and one in server mode. So configure the one in client mode first, add the Vtp domain. So if we look at our settings, if we do show Vtp status, R2 is one command we'll use a lot to look at VTP stuff, and we'll do show Vtp password because you have to use that one to show it. We don't have a password set. And another command we might use is show int trunk, because if we do not have a trunk, the VTP information will not be propagated to other servers. We must have trunking enabled for this to work. So we see the default setting is server with no domain name. So we want to set that information. We want to set the, what do we want to do first? We want to make one a client, one a server, and one a transparent mode. And we want to add a VTP domain. So we'll do the client mode first. So we'll call the VTP mode client. And we will set the VTP domain name to Rich is the best. Alright, so that's that on that. We'll go to the transparent mode switch next because that's what I said to do in the lab sheet. So VTP stat, VTP mode transparent, right? And VTP domain Rich is the best. I'm not sure this is going to work. No, it worked. And then we will go to the server. VTP mode server. VTP domain name Rich is the best. So these domain names are case sensitive. So if you have a lowercase Rich is the best and you put a capital R on one of the other switches, it's not going to work. So there we go. So we have a basic configuration for VTP. So what does that do for us? That allows us to add some VLAN information and have it be propagated to some of the other switches. So for example, on the server mode switch, I can add a VLAN. And I can change information about that VLAN. Name. Rich's VLAN. Right, so I can do this on a server mode switch. That's not what I wanted. In theory, if I had 1,000 switches, I would potentially have to go to each of those 1,000 switches and add that VLAN information. In practice, with VTP, if we come over here on the client and do show VLAN brief, if this worked as it's supposed to, my VLAN will now be here. So I added something on the server mode switch. It automatically got copied to every client mode switch. Let's check the transparent mode switch. So yeah, so the transparent mode switch did not get my new VLAN, and that's the way it's supposed to work. Transparent mode switches will receive those updates and pass them along. So if I had another switch over here off the transparent mode switch, in theory, it would get transported out to that switch. But transparent mode switches do not act on the changes. On a client mode switch, if I try to add a VLAN, it's going to say, sorry, sucker, you can't add a VLAN here. Go find a server and add it there. So client mode switches won't let you add VLANs. Transparent mode switches will let you add VLANs, and again, that information is local. If we look at our client or our server, that VLAN 100 did not get propagated over to here. So that's the basics of VTP. We tried to add a VLAN. We tried that was not. Delete VLAN 2 from the server mode switch. So we'll go up here to VLAN 2, and we will switch no VLAN 2, and this should have remove VLAN 2, and it did. If we go to our client mode switch, it should have removed VLAN 2. If we go to our transparent mode switch, did it remove VLAN 2? I hope you said no, because it did not. Right, so that removed VLAN 2 from the server switch. Fun times. We'll add it back because it might screw things up later if we don't have that VLAN existing on the switches. Let's look at something else. So yeah, so there we go. So alright, then step 19 says save your configuration, because I'm not exactly sure what is going to happen next. So let me explain that a little bit. We are about to connect our switches together with the other side. So an interesting thing about VTP, if you have a domain name configured and you do not have a password, if you connect an unconfigured switch or a switch with a default configuration, it's going to automatically take that configuration information. So let's get out of here and look at something. Show Vtp status. Right? We look at our configuration revision. We are at configuration revision 4. So every time we change something, let's add another VLAN for fun. Every time we change something, we get a new configuration number. So if you happen to connect two switches together and the stars align just right, you may accidentally overwrite your good information with bad information. So let's go ahead and set up this scenario so it does what I want it to do. What I want it to do is, this is what I consider to be my good network, if you will. I have VTP servers and VTP clients configured the way I want, and this over here is my network. I'm going to connect to it. Well, what I want to happen is I want for this network's VLAN information to overwrite the VLAN information for the other network. So in this case, I'm on revision 3, so I need to add some VLANs. I need to add some VLANs to make some different configuration numbers. That's not what I wanted. I'm at configuration 6. What am I at over here? I'm at 5. So in theory, when I connect these together, right, this is what I really want to have. This is my network. I have VLANs 2, 3, 4, 99, and 101. Those are in use, if you will, in my production network. I'm going to add these other switches in. Say I just acquired some new switches and did some lab testing, and I'm going to connect them in. They have some extra VLANs on there, and they don't have some VLANs I do need, namely 99 and 101. So when I connect these together and make it a trunk, what I'm expecting to happen is the VLAN database from this side is going to overwrite the information that is on this side. So this server mode switch with no domain name should join the rich is the best domain, and this information should propagate over to that switch and take over. When I say take over, I mean overwrite what this switch had. So first we got to connect it, then we need to make it a trunk. Int FA0/24. And I'll just hard code it, switchboard mode trunk. Alright, so in theory, once this trunk link comes up, we should have the VLANs that are on this guy. This guy should join the domain. Let's see if he did that yet. Show Vtp status. Oh, look, check it out. It joined my domain, right? Configuration 6. Let's go look and see what happened over here. Oh, I just gave it away with the wrong command. It joined my domain, and it had the configuration revision of 6 also. So if we look at the show VLAN brief output, my VLAN 99 and 100 or 101, whatever I had, went away, and these extra new VLANs came along. So I have, in essence, broken, those air quotes, in case you can't tell, I've broken my network by connecting two switches together with, you know, some of the one switch with the default configuration and the other switch with a partial configuration. So it took a lot of effort for me to line things up so they'll work this way. In the real world, it could happen, and you could be lost forever trying to figure out why. Imagine a scenario where you have a production network and a switch goes down, so you pull your switch out of the lab environment to plug into the production network to take the place of that switch that's down temporarily. Well, it's easy to imagine that in the lab environment you've made a lot more changes, so your revision number could potentially be higher than the production network. And in that scenario, if you have an unconfigured switch that you connect into your VTP domain with a higher revision number, you're going to lose the VLAN information from your existing network. So how do you prevent this? Use a password. If we had a password set on this switch, then when we connected another switch in, it would not have taken that revision information. So our next step is to go set a password, add a password, Vtp password, add that VLAN, add VLAN 5. So yeah, so we'll add a password on this switch, Vtp password rich, right? So now we have a Vtp password. So now if I add VLAN 5, which the lab sheet says, and go look at some of our other switches, VLAN 5 doesn't exist because these switches don't have the password. So now I'm not exactly sure what's going to happen. If I add the password, I don't know if it will automatically get VLAN 5. Yeah, so once I added the password, it accepted those changes. So if I go add the password to all the switches, then they will all get VLAN 5. Wrong password. VLAN 5. So what happens in the real world if you screw your network up by connecting the wrong switch to the wrong place? Well, you need to go back and recreate all those VLANs or recopy the config over, or something like that to fix the problem. Alright, so now all my switches should have passwords and they should have the things. Let me go ahead and add a VLAN 6. And then we'll go make sure that they got added to some of these other switches. VLAN 6. So now it's working great. So, yeah. So we had to add the password to all of our other VLANs to make sure that those switches would get it. So for fun, let's do what we just did, but now we have a password. So now I have a switch, a new switch. I'm going to go and I'm going to add some VLANs to change the revision number higher than, I don't know, what's the revision number now? Show Vtp status. So revision number is 8, so let me go add a bunch of VLANs over here to get my revision number up. VLAN 100, 1, 2, 3, oops, 3, 1, 4, 1, 5, 6. All right. So we have a bunch of VLANs. Our revision number is 10. So let's connect this switch together with this switch and make it a trunk and see what happens. My assumption is, since we have a password set, nothing's going to happen. Show in trunk is our good command for looking at trunking. It's set up for trunking. Show Vtp status. Yeah. So we're right. That's not all what I expected to happen. Configuration revision 10. So this is still 8. So I still have my good VLANs over here. So what happened the last time where my information got overwritten didn't happen this time. I was still surprised it took on this domain name, but since the password is not set, it was not able to pass that information over. So now I'm going to set the password and see what happens, because I don't know what's going to happen. Vtp Password. I would hope what happens is that this switch gets the information from the existing domain and doesn't overwrite the other domain. But I guess we'll find out in a second. Well, no, we overrode our information again. I wasn't expecting that to happen. I was expecting by having the password set, when we set the password, it would took over. But yeah, so apparently anytime your configuration revision is greater than the other switch, whichever number is greater will take over. So if you are adding a switch with a high configuration number, you can clear that out. Right? We can clear that out by deleting Vlan.dat, I think. That's not the one. Stupid. Yes. No, that didn't work. Alright, so I guess maybe you need to reload the switch before it comes back up with without that. So let's reload this guy. So back over here, we have our stuff all messed up, so let's go ahead and add back in our good VLANs that we needed. VLAN 2, VLAN 3, and VLAN 4. So those are ones we need. And hopefully when this guy comes up. When this guy comes up, we now don't have the VLANs we had before. And we don't have the VLANs we had before, and it's not a member of the VTP domain. So now if we go Once that interface comes up, I think it'll pick it up. So yeah, so deleting the VLAN.dat deleted the VLAN information from the switch, and there's no VLANs on the switch right now. So if we go, in theory, and add the VLAN, the Vtp domain again, and the password, then in theory we should have the VLANs now. We still don't have our VLAN. So our interface isn't trunking. So int fa0. Oh, because I didn't save the config. That's why. No, that makes sense. Didn't save the config, so it went away. Alright, so now it's trunking. So now I hopefully get my VLANs from the other switch. Trunk. And I got all the VLANs from the other switch. So that's VTP and how we can use VTP to propagate information among switches, and why you need to be careful when you are propagating information among switches. You might get some unexpected results.